Hello, 8th graders. We're going to be recording and watching a video on simplifying exponents. And as you can see, I'm on our home setup this weekend. And since I'm recording at home, we actually have a visitor who's going to come join us. You want to come join and say hi?
Hi.
There we go. Here's Corin. So while we are working on simplifying exponents, what are you going to be doing?
No. Yeah.
What are you going to be watching on TV?
The Star Wars show.
He's going to go watch a Star Wars show. So that should be pretty fun, but we're going to have a lot of fun learning about exponents too. All right, buddy?
I'll show the blast.
That's your blast? Whoa, that's pretty awesome. All right, you go have fun watching your show, buddy.
I have electricity and blast.
That rules, dude. All right. So he's watching Star Wars. We're going to be learning about simplifying exponents, which is Big Ideas, section 8.2 and 8.3. And if you're wondering, are monsters good at math? The answer is not usually unless you count Dracula. Let's get started here. So we just finished a review over exponents, and usually exponents are something like what we see here on the left, 3 cubed, which means 3 times 3 times 3, which is the simplified expression. Our final answer to this expression would be 3 times 3 is 9. 9 times 3 again is 27. And that's really everything we've done so far up to this point. If we have a problem like this where it's just x's, there's actually no answer for us to give. We can simply just simplify to show that x to the fourth means x times x times x times x. And then there actually is no answer unless the problem gave us a value of x. From here, we could even do this with fractions or decimals. 2 ways to think of this one. We could do 3 times 3 on the top and 4 times 4 on the bottom. We could also think of this as 3 squared on the top, 4 squared on the bottom, but regardless, we have an answer of 9 over 16. Now, the good news is for this section, we very rarely actually have to go to the final answer at the end, because instead of solving, most of the time we are just simplifying, which means making it simpler or making it into one individual term. So for example, here on the top, we want to combine all of this together into one individual term itself. Well, the best way to actually do it is to write out each individual piece. So 3 squared would just mean 3 times 3. 3 to the 5th would just be 5 more 3's. And our final term here, which is 3, is actually an invisible 3 to the first power, or 1 more 3 in this term. Our final answer to this problem would then be 3 to the power of 1, 2, 3, 4, 5, 6, 7, 8, or 3 to the 8th would be our final answer. And in this case, we actually don't need an answer that's more specific than that. We just need 3 to the 8th because we are simplifying, not solving. Well, if we have a problem like this that has x's in it, the process is very, very similar. We would do our 4 x's on the top, and then we would do our 2 x's on the bottom. Well, in our last problem, we had to combine all of these x's together because they were all on the top of the fraction. However, in this case, if we look at just this term right here, which is x over x, well, anything divided by itself is equal to 1. So these x's can be removed. If we look at these pair of x's here, the process is exactly the same. Again, we can simplify these to be equal to 1. Therefore, the end of our problem has x squared on the top, because I have 2 x's remaining, and there is nothing left on the bottom, which means we have the number 1. because you can always multiply any term times 1. So there's a hidden invisible 1 here at all times. If I put this down at a 0, I have now created an impossible problem. So the answer would be x squared over 1, or just x squared, because dividing by 1 doesn't change a problem. Well, we can get a problem that is slightly more difficult than that by combining those two terms together. So in this case, what we really want to know is how many total 4s are on the top of our fraction and how many total 4s are on the bottom of our fraction. Well, on the top, I could do 4 times 4 times 4 times 4 times 4, because I have 2 here and 3 here. Some of you may have already seen that the shortcut could be 2 plus 3 is 5, because there are 5 total on the top. Down here on the bottom, we have 1 4 here, 2 4s there. So we have 4 times 4 times 4 on the bottom, or again, shortcut would be 4 cubed. Well, I simplify as many 4s as I can, remembering that I can only simplify the terms that are identical to each other. So on the top, I have 4 squared. On the bottom, I have 1. 4 squared is equal to 16. So our answer could be either 16, or more than likely, your answer would just be the simplified fraction. In this case, we have variables, so the process is incredibly similar. That I have all of the y's on the top. So I have 2 y's, 3 y's, and 2 more y's on the back. So a total of 7 y's on the top. And the bottom has already been written out, so I have just 2 y's on the bottom, or y squared. Again, I simplify every identical term, because dividing by itself is equal to 1. And I would get y to the 5th on the top and nothing else on the bottom. You could also write this as y to the 5th divided by 1. Now, before we go into our final problem, the inevitable question is, where would I use this in the real world? And one of the very few times as an 8th grade student, I will tell you, probably never. This is really a math-only skill that will build to a really valuable real-world skill called scientific notation, but we're just not there yet. So this skill is very mathy. The benefit of a skill being very mathy is that there's probably not going to be a lot of story problems or real-world applications. We are just simply simplifying exponents and expressions to make the problem easier, but we aren't really doing a lot with the problem right now. So as tough as it gets, this is literally max difficulty. This will be as hard. Probably a good example of a level 3 or even a 4 question on the quiz coming up. So in this case, the process is the same. We have the terms that are together. So I have 12 over 3 is one constant term. Then here I have 6 y's, so I write those. And then on the bottom, I want to match up my y's. Well, I moved them over here to try to trick you so that there are 4 y's on the bottom. And then here I have 4 x's on the top. I'm going to try to not run out of room. Ugh, barely made it. And I have 3 x's. Whoops, that should be a times not equal. And 3 x's on the bottom. Once I've written the problem out, the simplifying part is usually not too bad. So 12 divided by 3 is just 4, or 4 over 1. For the y's, I can simplify 4 y's because the top and the bottom each have 4, which leaves me with y squared on the top. X's, I can get rid of 3 x's on the top and bottom, leaving me with 1 x on the top, which I could write as x to the 1st, or just x. So our answer to our problem, which seems a little bit weird, is 4y squared x, or x to the 1st. You could write this in any order because these terms are being multiplied together. So I could do 4xy squared, or I could even do x 4y squared. It doesn't matter as long as it is true and all of the numbers have been simplified correctly. That's really as tough as this section will get. Again, this right now is not a super real-world skill, but it will build into a real-world skill later in this unit called scientific notation. As always, if you have any questions, please let me know.